This assignment, you'll implement an out-of-block SLAM algorithm for mapping and localization. Experiment with the adaptive Monte Carlo localization package and implement the go-to goal with the WA local plan. You'll be using the actual Turtlebot3 for this assignment. Mapping with cartographer SLAM. Ross 2 defaults of the cartographer SLAM algorithm. You can find an alternate package here if you wish to use it later. So we'll be getting our power source here. Shit. Don't need the battery. Long power cable connected to the wall. When children are traumatized, one of the ways they cope with it is to soothe themselves.
Pasa el tiempo y no te veo. Dime dónde estás. Dime dónde estás. Te extraño el bellacao. Las noches de perreo. Dime dónde estás. Dime dónde estás. Que ando mirando la foto de cuando chingamos. Bonito recuerdos de cuando nos escapamos. Nos comimos en el carro al cuarto y llegamos. Desde que te mudaste, a mí me te mudaste. Estoy puesto para repetir, lo estoy en el balcón. No le traigo un plan, no tengo ninguna aplicación. Dime si fue que volviste con aquel cabrón, porque a mí no me molesta ser cuchillo. Tú no eres mamá, ni yo monaguillo. No tienes lo que ese culo te empillo. Si se abre un OnlyFans, la baby se hace mío. Queda loca, nunca le haga cosas con mi boca. Hace tiempo no la veo y ya toca. Ay, me tienes mirando la foto de cuando chingamos. Bonito recuerdo de cuando nos escapamos. Nos comimos en el carro al cuarto y llegamos. Desde que te mudaste, a mi mente te mudaste. Lo nuestro no te conviene, pero él ya no te entretiene. Sé que te insisto a pecar, lo tratas de controlar, pero no se detiene. Y déjame sentirte una vez, por si no te vuelvo a ver. Luego lo sigo normal con mi vida y tú la tuya con él, pero déjame sentirte una vez, por si no te vuelvo a ver. Luego lo sigo normal con mi vida, pero dale escápate y seguirte escápate, y allá va vacilándote, porque hoy te vas pa' casa y casi nunca te. Y si tienes problemas conmigo, pégate, que quiero ponerte a gritar mi nombre pa' que lo recuerdes. Siempre anda conmigo cuando el novio se le pierde, carita de nena buena nunca pierde. Conmigo se siente cabrón, él eso lo resuelve. ¿Y qué vas a hacer si me pego y te jalo por el pelo? Pa' mí que te va a gustar, solo déjate llevar y déjame sentirte una vez, por si no te vuelvo a ver. Luego sigo normal con mi vida y tú la tuya con él, pero déjame sentirte una vez, por si no te vuelvo a ver. Luego lo sigo normal con mi vida y tú la tuya con él, y tú la tuya con él. Yeah, 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 yeah. Ay, baby, yo quiero chingarte, te lo confieso, pero me conformo solo con un beso. Yo no creo en el amor ni nada de eso, pero no sé por qué ahora siempre que rezo le pido a Dios que cada vez que uno tú te vas, pero yo quiero continúo. Me pongo celoso cuando hablas de él. Dime qué vamos a hacer. Yo solo quiero hacerlo todo el amanecer, porque sé que pronto vas a desaparecer. Si fuera por ti te llevara de ira, creo que voy a extrañar la palma de ese que me mira con cara de nena buena, pero bellaquita. Esos ojitos que los poderes me quita. Quiero verte brincando toda mojadita, y tu cara cuando ya te pase la lengüita, y te trae un whiskycito con agüita tónica. Yo sé que no eres bien, que no eres católica. Lo más que me gusta es que tú eres medio complicada. Quiero ver cómo tus ojos se ponen con indicado, verdecito colorado. No sé si se nota, me tienes desesperado. Soñando contigo todas las noches te he pelado. Déjame probar, pica por su lado. ¿Y qué vas a hacer si me pego y te jalo por el pelo? Yo sé que te va a mojar, solo déjate llevar y déjame sentirte una vez, por si no te vuelvo a ver. Luego lo sigo normal con mi vida y tú la tuya con él. 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 Tú la tuya con él.
How do I change the parameter?
Si estás, yo quiero saber si tú te vas, mami, cuando tú quieras, cuando tú quieras, yeah, yeah. Nadie te está aguantando y la puerta está abierta. No te preocupes por nosotros dos, la historia ya está muerta. Espero que seas feliz y que te diviertas. Pero para que no vuelvas, no, 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 no. Nadie te está aguantando y la puerta está abierta. No te preocupes por nosotros dos, que tu historia ya está muerta. Espero que seas feliz y que te diviertas. Pero para que no vuelvas, no, 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 no. Hey, dime qué esperas. Baby, te quiero ver afuera. Eres alguien por dentro y está por fuera. Y yo no siento nada cuando te alguien por dentro y está por fuera. Y yo no siento nada. Dame que manda. Se acabó, por ti ya no siento nada. De nuestra serie ya no sale en temporada. Así que vete lejos, dile a Leo que te envíe el ping. Hace tiempo que no somos un team. Para el carajo nuestro aniversario y San Valentín. La prima Cristian Yuri lo trae en satín. Sigue lo que te duele. Que tiene la culpa es lo que te muerde. Quédate con el pelo para que de mí te acuerdes. Y piensa en todo lo que te pierdes. Pero te deseo suerte, ahora soy más fuerte. Gracias a todo lo que me hiciste. Tú nunca me quisiste. Gracias a todo lo que me hiciste. Tú nunca me quisiste. No sé por qué me hiciste. Seas feliz y que te diviertas, pero pa' que no, nadie te está aguantando y la puerta está abierta, no te preocupes por nosotros dos, que la historia ya está muerta, pero que seas feliz y que te diviertas, pero pa' que no,
Okay. How are we gonna tune this? Tuning the car. I can't even say this word, man. Let's go to Señor Google. Pronunciation.
Cartographer. Cartographer.
Cartographer.
Tuning Cartographer is unfortunately really difficult. The system has many parameters, many of which affect each other. This tuning guide tries explain a principled approach on concrete examples. Cartographer provides built-in tools for SLAM evaluation that can be particularly useful for measuring the local SLAM quality. They are standalone executables that ship with the core Cartographer library and are hence independent, but compatible with Cartographer ROS. Therefore, please head to the Cartographer Read the Docs evaluation site for a conceptual overview and a guide on how to use the tools in practice. For this example, we'll start at Cartographer Commit ABA 4575 and Cartographer ROS Commit 99C23B6 and look at the bag B220160427123141.bag from our test data set. At our starting configuration, we see some slipping pretty early in the bag. The backpack passed over a ramp in the Deutsches Museum, which violates the 2D assumption of a flat floor. It is visible in the laser scan data that contradicting information is passed to the SLAM. But the slipping also indicates that we trust the point cloud matching too much and disregard the other sensors quite strongly. Our aim is to improve the situation through tuning. If we only look at this particular submap, that the error is fully contained in one submap. We also see that over time, Global SLAM figures out that something weird happened and partially corrects for it. The broken submap is broken forever though. Since the problem here is slippage inside a submap, it is a local SLAM issue. So let's turn off Global SLAM to not mess with our tuning. To tune local SLAM for lower latency, we can increase voxel filter size, increase submaps dot resolution. For the adaptive voxel filter, decrease min number points, max range, increase max length, decrease max range, decrease submaps dot number range data. In our case, the scan matcher can freely move the match forward and backwards without impacting the score. We'd like to penalize this situation by making the scan matcher pay more for deviating from the prior that it got. The two parameters controlling this are trajectory builder 2D.series scan matcher.translation weight and rotation weight. The higher, the more expensive it is to move the result away from the prior, or in other words, scan matching has to generate a higher score in another position to be accepted.
lección, yo te mando mi carta. Si me das tu cuenta de banco, $1,000,000. Toda la noche yo a Dios le rezo, porque antes que se acabe el año tú me das un beso. Y empezar el 2023 con cuidado, tú te ves como me conoces más, me matas sin un pistolón. Y yo te compro un Benchis, Gucci y Benchi, un poodle, un Frenchie, el panto, los Monchi. Me canto un mariachi, me convierto en un techi. Ya, 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 ya. Pasa el tiempo y yo sigo aquí. No se traiciona, la familia nunca abandona. Pasa el tiempo y yo sigo aquí. No se traiciona, la familia nunca abandona. Y no se cambia. Primo dinero, buena mujer, que la envidia no vive, con nosotros se muere, y yo me cambia. Primo dinero, buena mujer, que la envidia no vive, con nosotros se muere. Yo, el tiempo pasa, no se detiene, yo me estoy poniendo viejo, ayer era un nene, hey, los problemas van y vienen, hey, pero esto es lo que me entretiene, y yo, con mi Dios, siempre estoy agradecido por todo lo que he logrado y he vivido, por todo lo que he llorado, por todo lo que he reído, por los hermanos que están y todos los que se han ido. Ay, que desde el cielo me vigila, momentos que remate motilan. Aquí estamos activos, pero nunca lo olvides. Y espero que si puedes nos cuides porque y espero que si puedas nos cuides porque y espero que si puedas nos cuides porque la galleta que me da, siempre andaba en el aseo, la máquina de museo, la paseo porque la galleta que me da, nos pintamos de los feos, pues después ya se conteo, aquí no lo veo, ay, tú ni sé que le metí cabrón, ya ni que eres un mamón, ay, tú no sales conmigo ni mi peor día, y ni me pego para la portería. Diablo, llama la puntería. Tengo todos los sabores, una heladería. Y mi nombre te pesa y te pega en la lotería. Moviéndome, como el pecho se movía. Despistado, pa'l porche, yo el día, los ponches. Que me reo, yo donche. No me andan, los planches. Y no hicieron ni media. Mira la estrella. Lo tuyo es cooperar, lo tuyo es pelea. Lo mío es cultura. Hay que hacer Coca-Cola. La galleta que pela. Siempre andamos en el aseo. La máquina de museo. La paseo porque la galleta que pela. Nos cuidamos de los feos. Poder follar que conteo. Aquí no los veo. La galleta que pela.
If a separate odometry source is used as an input for local SLAM, we can also tune the global SLAM to benefit from this additional information. There are in total 4 parameters that allow us to tune the individual weights of local slam and odometry in the optimization. We can set these weights depending on how much we trust either local slam or the odometry. By default, odometry is weighted into global optimization similar to local slam poses. However, odometry from wheel encoders often has a high uncertainty in rotation. In this case, the rotation weight can be reduced even down to 0. Exploiting the map generated by cartographer ROS. As sensor data come in, the state of a SLAM algorithm such as cartographer evolves to stay the current best estimate of a robot's trajectory and surroundings. The most accurate localization and mapping cartographer can offer is therefore the one obtained when the algorithm finishes. Cartographer can serialize its internal state in a stream file format, which is essentially a compressed protobuf file containing a snapshot of the data structures used by cartographer internally. To run efficiently in real time, cartographer throws most of its sensor data away immediately and only works with a small subset of its input.
To run efficiently in real time, Cartographer throws most of its sensor data away immediately and only works with a small subset of its input. The mapping used internally and saved in the .pb stream files is then very rough. However, when the algorithm finishes and a best trajectory is established, it can be recombined a posterior with the full sensor's data to create a high-resolution map. Cartographer makes this kind of recombination possible using Cartographer Assets Writer. The Assets Write takes as input 1. The original sensor data that has been used to perform SLAM in ROS.bag file. 2. A cartographer state captured while performing SLAM on the sensor data. 3. The sensor extrinsics. Oh my god, I can't even say that word. 4. In a pipeline configuration, which is defined in a Lua file. The asset writer runs through the .bag data and batches with the trajectory found in the .pb stream. The pipeline can be used to color, filter, and export SLAM point cloud data in a variety of formats. There are multiple such points processing steps that can be interleaved in a pipeline. Several ones are already available from cartographer.io. When running Cartographer with an offline node, a .pb stream file is automatically saved. For instance, with the 3D backpack example. Watch the output on the command line until no terminates overwritten that, which represents the cartographer state after it's being processed and finish all optimization. When running as an online node, Cartographer doesn't know when your bag ends, so you need to expose the services to explicitly finish the current trajectory and make Cartographer serialize its current state. Finish the first trajectory, no further that would be accepted on it. Raw service call, finish trajectory 0. Ask Cartographer to serialize its current state, raw service call, write state, blah, blah, blah. Once you receive your .pb stream file, you can run the assets writer with the same pipeline from the 3D pack. Cartographer is a complex system, and tuning it requires a good understanding of its inner workings. This page tries to give an intuitive overview of the different subsystems used by Cartographer, along with their configuration values. If you're interested in more than an introduction to Cartographer, you should refer to the paper. One describes a 2D SLAM, but it defines rigorously most of the concepts described here. Those concepts generally apply to 3D as well. Let's open up this 2D paper. Real-time loop closure and 2D ladder SLAM. We're going to hit download. God damn. As built for plans are useful for a variety of application, manual surveys to collect this data for building management tasks, typically combine computer-aided design with laser tape measures. These methods are slow, and by employing human preconceptions of buildings as collecting straight lines, do not always accurately describe the true nature of the space. Using SLAM, simultaneously localization and mapping, it is possible to swiftly and accurately survey buildings of sizes and complexities that would take orders of magnitudes longer to survey manually. Applying SLAM in this field is not a new idea and is not the focus of this paper. Instead, the contribution of this paper's novel method for reducing the computational requirements of computing loop closure constraints from laser range data. This technique has enabled us to maintain a very large floor. Son of a bitch. Has enabled us to map very large floors, 10,000 square meters, while providing the operator fully optimized results in real time. Our system combines separate local and global approaches to 2D SLAM. Both approaches optimize the poses zeta equals zeta x, zeta y, zeta theta, consisting of xy translation and rotation of zeta theta of lidar observations, which are further referred to as scans. On an unstable platform such as our backpack, an IMU is used to estimate the orientation of gravity for projecting scans from the horizontally mounted lidar onto the 2D world. In our local approach, each conjective scan is matched against a small chunk of the world called a submat. Using a non-linear optimization that aligns the scan with the submat, this process is further referred to as scan matching. Scan matching accumulates error over time that is later removed by a global approach was described in section 5. Scan, submaps, skip. Series scan, man. Prior to inserting scan into submap, the scan poses data is optimized relative to the current local submap using series-based scan matcher. The scan matcher is responsible for finding scan poses that maximize the probabilities at the scan points in submap. We cast this as a non-linear least squares problem. That's good to know. Cartographer Slam consistently performs within our expectations. What? Even in the case of the MIT CSAIL, where we perform considerably worse than graph mapping. This paper presented an experimentally validated 2D SLAM system that combines scan to submap matching with fluke closure detection and graph optimization. Individual submap trajectories are created using our locals grid-based SLAM approach. In the background, all scans are matched to nearby submaps using pixel-accurate scan matching to create loop closure constraints. The constraint graph of submap and scan poses is periodically optimized in the background. The operator is presented with an up-to-date preview of the final map as a GPU-accelerated combination of finished submaps, and the current submap we demonstrated that is possible to run our replicas on modest hardware in real time. This didn't help at all. Cartographer can be seen as two separate but related systems. The first one is local SLAM, sometimes also called the front end. The other system is global SLAM, sometimes called back end. On a high abstraction, the job of local SLAM is to generate good submaps, and the job of global SLAM is to tie them most consistently together. Our inputs. Range finding sensors, for example LiDARs, provide depth information in multiple directions. However, some of the measurements are irrelevant for SLAM. If the sensor is particularly covered with dust or if it's directed towards part of a robot, some of the measured distance can be considered as noise for SLAM. On the other hand, some of the furthest measurements can also come from undesired sources, reflections, sensor noise, and are irrelevant for SLAM as well. To tackle those issues, Cartographer starts by applying a bandpass filter and only keeps range values between a certain min and max range. Those min and max values should be chosen according to the specifications of your robot and sensors. In 2D, Cartographer places ranges further than max range by trajectory builder. Also provides maxi, yada yada yada. Distances are measured over a certain period of time while the robot is actually moving. However, distances are delivered by sensor in batch and large raw messages. Each of the message timestamps can be considered independently by the cartographer to take into account deformations caused by the robot's motion. The more often cartographer gets measurements, the better it becomes at unwarping the measurements to assemble a single coherent scan that could have been captured instantly. It is therefore strongly encouraged to provide as many range data by scan as possible. Range data is typically measured from a single point of the robot, but in multiple angles. Blah, 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 blah. After having applied a fix, what is a voxel filter? However, simple random sampling would remove points from areas where we already have low density of measurements, and the high area density will have more points than needed. To address that density problem, we can use a voxel filter that downsamples raw points into cubes of a constant size, only keeps the center of each cube. A small cube will result in more dense data representation, causing more computations. A large cube size will result in data loss, but will be much quicker. After having applied a fixed size voxel filter, cartographer also applies an adaptive voxel filter. This filter tries to determine the optimal voxel size to achieve the target number of points in 3D, 2 plus blah, 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 blah. An inertial measurement unit can be a useful source of information for SLAM because it provides an accurate direction of gravity and a noisy but good overall indication of the robot's rotation. In order to filter the IMU noise, gravity is observed over a certain amount of time. If you use 2D SLAM, range data can be handled in real time without an additional source of information. So you can choose whether you like the cartographer to use an IMU or not. With 3D SLAM, blah, 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 local SLAM. Once the scan has been assembled and filtered for multiple range data, it is ready for the local SLAM algorithm. Local SLAM inserts a new scan into its current submat by scan matching using initial guess from the pose extrapolator. The idea behind the pose extrapolator is to use sensor data of other sensors besides the rangefinder to predict where the next scan should be inserted. 2 scan matching strategies are available: series scan matcher, real-time correlative scan matcher. Either way, series scan matcher can be configured to give a certain weight of each input. Yada, yada, yada. Jeez, bro. The series scan matcher gets its name from Series Solver, a library developed by Google to solve non-linear least squares problem. Ooh, that's pretty cool. God damn.